So hey guys, this is Dipesh, and in this particular video we'll be looking into a special type of network called as LSTM, and we'll try to implement sentiment analysis. Okay, so yeah, the first thing that you will do is that we'll first download our dataset. Okay, and the dataset that we'll use is called as IMDb dataset. So just go on to your Google and type IMDb dataset, and just click the second link that you will get. Okay, that will take you to kaggle.com. So IMDb dataset it's basically a dataset of 50,000 movie reviews. Okay, and basically it has two main columns. First is the review column and second is the sentiment column. So there are two types of sentiments, positive and negative. So if the review is positive, then the sentiment is also positive, and if the review is negative, then the sentiment is negative. Okay, so what we'll do is try to uh, implement this for sentiment analysis. So for example, if we give a review to our RNN model, then what we want is we want the RNN model to predict if the sentence or the review is a positive review or a negative review. Okay, so positive will be represented by 1 and negative will be represented by 0. Okay, and we want our LSTM model, our RNN model, to give us a probability, whether the probability between 0 and 1, so that we get an idea of what the model thinks. Okay, so let's implement it. So just download this dataset. Okay, just download this dataset. It's somewhere around 66 megabytes. Okay, I've already downloaded it, so I won't download it. And once you have downloaded the dataset, what you do is open your Google Colab and upload your dataset. Okay, so just click on this symbol, and it will automatically open your file open your file manager, and just choose the dataset. Okay, and once you have uploaded the dataset on your Google Colab, now we are ready to implement our LSTM network. So what we'll do is we'll first copy its path, and I will just paste it here. So I'll do path is equal to this. So this is our path. Let me also add some columns here, add some rows here. Okay, now the next thing that we'll do is we'll implement some necessary libraries. Okay, so we'll import numpy, and then we will import pandas. Okay, then we'll import two very special functions. So we'll do from keras dot preprocessing dot text import one hot. Okay, so this one hot function will help us convert text data into numerical data. That is, it will help us convert words into vectors. Okay, so next we'll import from keras dot preprocessing dot sequence import pad sequences. Okay, now as we go forward, I will tell you what this pad sequence does. Okay, it is basically used to pad sentences so that have similar length. So don't worry about it. As we go forward, I will try to explain it. So now let's read our dataset. First, let's run it. Okay, now let's read our dataset. So I'll do df is equal to pd dot read csv, and I will give it the path. Okay. Okay, let's also print the first 10 samples and see how it looks. Okay, so now what I will do is this dataset contains around 50,000 samples. So I won't use 50,000 samples. I will only use 100 samples. This is because if I use the entire dataset, it will take at least around like 10 to 15 minutes to just train the model. Okay, so to just give you an idea, uh, uh, just demonstrate how we implement sentiment analysis, what I will do is I will just train 100 samples, but on your local machine you can try to train on this entire data set. Okay, all right, So let me run this again. Okay, on your local machine, just remove this n rows. Okay, just remove this n rows, and just try to train the entire model using the entire data set. So the next thing that we'll do is we'll convert the sentiments from categorical values to numerical values. Okay, so positive will be 1 and negative would be 0. So we won't use something like one-hot encoding or anything. We'll just simply replace the strings with integer values. Okay, so how do we do that? We'll just write replace. What I'll do is I'll do df, I'll write sentiment, and I'll do dot replace. So this replace function basically takes a dictionary. So the key would be the new string value, and the value for this key would be the integer that we want to replace it with. Okay, then we'll do the same thing for negative, and we'll replace negative with 0. Okay, and I will also do implace is equal to true. Now again, let's print the dataset again. So you can see the positive string value has been replaced with 1 and negative had been replaced with 0. Okay, so now the next step is we have to convert the sentences into vectors. Okay, but before doing that, we have to do 2 extra steps. We have to basically filter these sentences. So by filtering, I mean we have to firstly lowercase all the sentences, and we have to remove the extra special characters. Okay, like the comma, exclamations, and the full stops. Okay, so what we'll do is I will just copy and paste a piece of code. Okay, so that will help us save some time. So what I will do, I will just paste this code. Okay, I will explain this, but before implementing this code, let's define our x and y. Okay, so x would be basically a numpy array of our reviews. So I'll do np is equal to array, and then I will do df review. Okay, and then I will do values. So our x would be a numpy array of all the reviews, and our y would be a numpy array of zeros and ones. Okay, so I'll do df, and I'll do sentiment dot values. So let's run it. Alright, now what we'll do is we will what this piece of code does is it basically takes each review from x. Okay, and firstly it reviews basically it lower cases that entire review. Okay, so it lower cases the entire sentence, and then basically for each word in one review, it basically checks if there is any special character. If there is any special character, then it will replace that character with empty space. Okay, so what I will do is I will write filtering. Okay, filtering sentences, and at the end of this I will print x filtered. Okay, x filtered will contain our filtered reviews. Alright, so let's run this. Also, don't worry if you're not getting this. You can find this entire code or this entire notebook on my GitHub. Okay, so if you go on GitHub, on my GitHub profile, just go to github.com dipeshdm. Okay, this is my profile. Just click on my repositories, and you will find a repository called as MLDL course. Okay, if you again click on this repository, you will find the code for all the lectures here. Okay, so even if you don't understand it in this video, just try to download this entire code and try to implement this notebook on your own. Okay, alright, so you can see our reviews has been filtered, and you can see that all the words, all the sentences are in lowercase, and all the special characters like comma, full stops, exclamation, all have been removed. Okay, So now we have successfully filtered our training data set. Now there is only one step remaining, that is splitting the data set. Okay, I'm sorry, there's only one step now remaining, that is we have to convert our sentences or convert our reviews into vectors. Okay, and how we'll do it, we'll do in it using one hot encoding. Now I have explained how we apply one hot encoding in our uh, previous video. So if you don't know how to convert sentences into new numbers using one hot encoding, just watch the video again. Okay, so what I will do is I will write converting sentences to vectors. Okay, and you see we have already imported the one-hot function. This one-hot function that we imported from preprocessing.txt is basically a special type of function made specifically for converting for implementing one-hot encoding on words and sentences. Okay, so what I will do is I will do firstly I will define what is the vocabulary size. Okay, vocabulary size. Vocabulary size means how many unique numbers, how many unique words are there in our entire data set. Okay, now since we are using a test data set, we already know that there are 5000 unique words in our data set. But in real life cases, you have to basically create a piece of code that will count the number of unique words in your data set. Okay, so next what we'll do is I will write one hot encoded. Okay, one hot encoded variable will basically hold our reviews. Okay, reviews which has been converted from string to vectors. So I will do one hot. Okay, this one hot function is the same function that we imported here. Okay, and now what I will do is I will give it our review and I will give it our vocabulary size, and this will happen for each and every review. So I will write as for review in X filtered. So for every review in X filtered, this function will be called. Okay, so now once this is done, we'll let's print this. Okay, let's run this and see what we get. Okay, so now you can see that let me just use the print function. Okay, we can see this more clearly. So I'll write print. Okay, let's run this again. Okay, now you can see that each word or each sentence has been converted into a specific vector. Okay, now since our vocabulary size is 5000, each word would be represented by a vector of size 5000. Okay, now now this is still a very huge inefficiency of using one hot encoding, because in order to just represent one word, we have to we have to create a vector of 5000 numbers. Now that is a huge waste of memory. Okay, so in order to prevent this, in order to reduce the size of these vectors, what we do is we use a special type of layer called as embedding layer in our neural network. Okay, so as we go forward, I'll explain it. So now our sentences have been converted into vectors. So all the pre-processing steps have been completed. The only step remaining is that we have to split our data set. So what I will do is I will do firstly I will split the data set. Okay, firstly I will split the data set. Xtrain, Xtest, Ytrain, Ytest. Okay, now even before before splitting our data set, we also have to do one very important step, which is called as padding. Okay, padding, padding the sentences. Now what padding means is that in our data set we have sentences of varying length. Okay, so for example, one sentence may have 10 words, or another sentence may have let's say 20 words, etc. So we have sentences with different number of words. But what we want is, in order to train a recurrent neural network using textual data, we want all the sentences to have a fixed length. Okay, so in order to do this, what we do is we apply something called as padding. Now padding is very simple. Since all our sentences are since all the words in a sentence are vectors, what we do is we just simply add 0 vectors to all the sentences in order to bring all of them to a fixed size. Okay, so for example, if there are two sentences where one sentence has 10 words and another sentence has 20 words, then what will happen is one the first sentence, which has 10 words, that is 10 vectors, we will add another 10 0 vectors on top of it, so that it has the same length as the second sentence. So now both the sentences have similar length. So padding is nothing but just adding 0 vectors so that all the sentences in our dataset have similar length. So how do we apply padding now? So before applying padding, we have to decide on a max length. Okay, that what would be the length of all the sentences. Now usually the max length is basically the length of the longest sentence in your data set. Okay, so since this is a test data set, we know that the longest sentence in our data set has 500 words, so we are using 500. Okay, so now the next thing that we'll do is we'll do x padded is equal to pad sequences. Okay, the pad sequences is the same function that we imported here. Okay, pad sequences. Now what this pad sequence takes is it takes our encoded x and it takes the max length. Okay, so we'll pass it our one hot encoded and it will take our max length. Another thing it takes is the input size or the input length. I'm sorry, it takes padding. Okay, it takes padding, what type of padding we want. So there are two types of padding. First is post padding and pre padding. So in post padding we add 0 vectors at the end of the sentences, and in pre padding we add 0 vectors at the start of the sentence. Okay, nothing hard, it's a very simple concept. So we'll use post padding in this method. Okay, so once this is done, let's run it. Okay, now we have successfully padded our sentences. Now we can split our data set. So before splitting it, let's import the splitting function. So what we'll do is I'll do from sklearn dot model selection import train test and split. Okay, and this will take our x padded and it will take y and it will take test size. Okay, so we'll be using 30% of our dataset as test for test purpose. So I'll write 0.3, which means 30%. Okay, let me write splitting the dataset. Okay, all right, so let's run it. Okay, now let's run it. All right, so we have so again what we did was we imported our dataset, we replaced the sentiment with 0 and 1. Okay, then we filtered all the sentences. Okay, basically by filtering I mean we lowercase all the sentences, and then we removed all the special characters like dots, full stops, exclamation, all those stuffs. Okay, Then what we did was uh, we converted our reviews, that is sentences, into vectors using one hot encoding. Okay, and after that what we did was we applied padding so that all the reviews, all the sentences have a fixed size. Okay, now now what we'll do is we'll create our model. So in order to create our model, we'll basically import two things. First is the sequential model, and second is the layers. So what I'll do is I'll write model creation, and I will write from keras dot models import sequence, import sequential. And then what we'll do is I'll import from keras dot layers import dense, and import LSTM and import embedding. Okay, so LSTM is basically our recurrent neural network. Dense is basically our multi-layer perceptron, that is a fully connected layer which we will add at the end of the LSTM, so that we will get a probability as the output. And embedding is basically a special type of layer. Let's see what it does. Okay, so what we'll do is we'll do model is equal to sequential. Okay, and we'll do model dot add, and the first layer would be the embedding layer. Okay, now what embedding layer does is it basically transforms our vectors. Okay, so we know each word in our data set is now represented by a single vector, but the size of this entire vector is very huge, which is basically an inefficiency. So in order to represent one word, we have to create a vector of 5000 numbers. So in order to reduce the size of this vector and add some semantic meaning, we use the embedding layer. Okay, so the embedding layer basically takes two important parameters. Firstly, it takes the vocabulary size, and then it takes over the embedded vector size. Okay, embedded vector size is basically what is the size, how much do we want to reduce the original vector. Okay, how much, for example, if size of our vector is 5000. Okay, then if you, let's say we want to convert this 5000 numbers, that is the vector of 5000 numbers, into a vector of 100 numbers, then our embedded vector size would be 100. Okay, so here what we'll do is we'll first pass the vocabulary size, and then we will pass the embedded vector size. Okay, embedded vector size is basically uh, the size that to which we want to convert our original vector. So I will do embedded vector size is equal to 35. Now our since each word is represented as a vector of size 5000, we will convert each vector into a vector of 35 numbers. Okay, now another important thing it takes is the max length. Okay, max length. So we'll do input length, and input length is basically the max length, that is what is the size of each sentence. Since we set max length as 500, that is each sentence or each review will contain 500 vectors. Okay, so we'll pass that, and now let's add another layer. So we'll add model dot add LSTM. Now LSTM takes one main argument, which is the length of the hidden state vector. Okay, so we'll keep it as 100, and let's add a dense layer. Okay, dense layer. Now dense layer will again take another another argument that is the number of nodes. Okay, since we want a probability value as the output, we'll use only one hidden layer. Okay, we'll basically use only one node in our output layer, and we'll use the activation as sigmoid since we want a probability value between 0 and 1. Alright, now the next thing that we'll do is we'll print the summary of this model. So summary will basically print the number of parameters and also some important things. Okay, so let's print this. Okay, so you can see here that the total number of trainable parameters are somewhere around 229,000. Okay, 229,000. Now that's still a pretty huge number of trainable parameters, since we cannot since it makes it very difficult to train this even a simple recurrent neural network on a local machine. Okay, so without GPU it's very hard to train this kind of neural networks. Okay, so yeah, if you don't have GPU and all, just use Google Colab. Google Colab basically provides some very impressive GPUs in the backend. So okay, so now we have created our model. So next thing that we have to do is we have to train our model. Okay, so I'll write training the model. Okay, training the model. All right, now training the model is pretty simple. All you have to do is we have to apply two functions, that is model.compile and model.fit. So we'll do model.compile first, and what model.compile takes is it takes the optimizer loss function and the matrix that we want to print. So we'll keep the optimizer as it is, and we'll do the loss function. We'll do, since we have two classes, okay, positive and negative, we'll use the binary cross entropy loss function. So I'll write binary cross entropy. Now I talked about cross entropy very briefly in our first lecture. Okay, so if you don't know what loss function or cost functions is, just go and watch that video again. Next thing we'll do is we'll give it what matrix do we want to predict. We want to print during training. So we want to look at accuracy. So we'll pass it accuracy. So next thing we'll do is model.fit, and model.fit will basically take multiple parameters like x, y, batch size, number of epochs. Okay, so we'll pass it our x train, we'll pass it our y train, and we'll pass it the number of epochs. Okay, and then we will now once we run this cell, it will start training. Okay, all right, so let's run this. So now you can see the training has started, and you can see our accuracy is increasing and our loss is decreasing. Okay, so after 10 epochs our training has been completed. So what we'll do is we'll now see what is the accuracy of our model on our test dataset. So I'll do score is equal to model dot evaluate, and we'll pass it our x test, and we'll pass it our y test, and we'll see, and we'll then print the accuracy. Okay, let's run it. Okay, so you can see that since we are using only 100 samples, it's not giving us any great accuracy. The accuracy that it gave us is somewhere around 46%. Okay, now it's okay because we are not using the entire data set. On your system, when you are running, just remove this thing. Okay, just remove the n rows. Okay, and and implement and try to train this network using the full data set. Okay, so now we know how to train the network. Now we also know how to find the accuracy of our model. Now let's try to run an inference. Okay, let's try to give it a sentence, and let's see if it predicts it correctly or not. Okay, now again the accuracy is very low, so I'm not trying to achieve some accuracy here. Okay, I'm just trying to show you how we actually implement this. Okay, how we actually implement this. So before running an inference, what we'll do is we'll save this model. Okay, we'll save this model. So how to save this model? Saving a model is very easy. All you have to do is just do model.save and pass the name of the file. Just pass the path of the file where you want to save it. So I'll do model.save and I will save it as IMDb sentiment analysis. So it will basically save the entire model. It by saving the model, which we mean it will save two things. First is the learned parameters, and the second thing is it will save is the architecture. Okay, so yeah, let's save it. Let's run it. Okay, so now you can see, if you open this folder, you'll see a new file with the name that we saved the model. Okay, this is our saved model. So whenever you want to deploy a model on a server or anything, just download this file. Okay, just download this entire folder, and all you have to do is just do model.load and then give the path to this folder. So this is how you basically download the entire model and deploy it as a REST API. So now we have saved the model. Now what I will do is I will try to load the model. Now how do we load the model? Now how we load the model is, it's very simple. So firstly we have to import the load function. So what we'll do is we'll do from keras.models import load model. Okay, and all we have to do is we just have to do model, we just have to do load model and give it the path to the file and give it the part where the file is saved. So I'll just copy this file and I will just pass it this path. Okay, now if when we run this, now our model will be loaded in this variable. It will be loaded in the trained model variable. Okay, now let's run an inference. So in order to run an inference, what we have to do is when we give a sentence, we have to basically follow the same procedure that we did here. So when we get a sentence, we have to first lowercase the sentence, then we have to again check for special characters and remove them, and then we again have to basically apply one-hot encoding, that is convert them into numbers or vectors, and then we again have to apply padding. So whenever you will be running an inference, we have to follow all the steps again before giving an input to our model. So to prevent wasting any time, what I'll do is I'll just quickly copy and paste a piece of code. Okay, so this piece. Okay, so this is basically a method that I created. What it does is it takes a string sentence and it does all the pre-processing steps. It again loads the model and stuff, and then it basically does a prediction. And you can see that what I have done is, if the probability is 0.6 is greater than 0.6, then it is a positive sentence, or it is a negative sentence. So what I will do is I will reduce the threshold from 0.6 to 0.5. Okay, also let's copy the path again. Let's copy the path again, and now let me replace the path here. Let me replace the path of the training model. Okay, now let's run this. Alright, so now what we have to do is we just have to do result is equal to, and we have to call this function. So we'll do get sentiment and we'll pass it a sentence. So what I'll do is I'll say that movie was good. Okay, and I will then print the result. Now let's see how the model performs. Now the accuracy is pretty low, so I'm not expecting here to give it any good results or anything. So as you can see, we even though we passed a positive sentence, we got a negative result. Now this is okay because we are not trying to achieve some high accuracy or anything. I'm just trying to show you how to implement this thing. Okay, so this is how we basically implement sentiment analysis using recurrent neural network, that is LSTM.